Hey guys, what's up? Welcome to the last day of erosion and deposition. Yay! Okay, so today we're going to finish up with running water's deposition. We're going to talk about that, and then we're going to talk about beach erosion and beach deposition. I know it's still water, but it's slightly different, works different ways, different things are going to go on. So it's important that we do that as a separate category. All this information is on your quiz today. Your quiz today will be between 9 and 3 o'clock. You have to complete it. It is a 10-minute quiz. It is on Test Wizard. This material that will come up after this will be on it. So watch the video first. You will have a test on all this stuff next Tuesday. Okay? It'll be on all weathering and erosion, all the stuff that we have talked about. Okay? Monday will be a study day. We will be giving office hours. Check the Google Calendar. I'm not sure which time we're going to do it yet, but check the Google Calendar in case you have any questions so that we can go over that. Okay? But without further ado, let's go. Now, yesterday we did mention deposition a little bit when we were talking about meanders and stuff like that, but we're going to focus on that a little bit more today. Now, what are we talking about with deposition? We're talking about the stuff that gets dropped off. So remember, when we're talking about weathering and erosion, we have that agent of erosion, the thing that actually does the moving and the carrying. That would be the running water. So we're talking about the running water carries the sediment, and it carries the sediment until it drops it off. Once it drops it off, we call that a deposition. Okay? So when we're talking about the deposition of running water, okay, what are we talking about? Well, what basically happens is all that stuff that gets carried, like we were talking about, the load that the stream is carrying, is going to be carried as long as the stream is moving at a certain speed. As that stream slows down, as it decreases in velocity, sediment begins to drop out. The heaviest stuff gets dropped out first, and then the medium-sized stuff, and eventually the lightest stuff. Okay, so it's kind of the slower the stream goes, the more stuff is going to get dropped off. So when the stream is traveling very, very fast, it can carry just about everything. But the very large things are going to get dropped off. When the stream decreases to a medium speed, it's going to no longer be able to carry big things. It's going to start dropping us off. So if we look back at the chart in the reference table, we can actually see that. Okay, as the stream slows down, so if we go backwards down the curve, we see it can carry less and less and less. Now, what this results in is stream sediments being very well sorted. What does this mean? This means it's very rare that you tend to find a jumble of material and say that was deposited by a stream. Most streams tend to deposit stuff in an organized pattern. So if you look at the picture in front of you, you can actually see this. Okay, you can see that there's where all the big pebbles are, and you see how it progressively gets smaller and smaller and smaller and smaller. So if you were looking at this, you could say, okay, the stream was traveling at a certain speed at the bottom of the page and a different speed at the top of the page. It was slowing down. This is dramatically different from a glacier, and this is one of the ways in which you can tell if something was deposited by a glacier as opposed to a stream. Glacial deposits tends not to be sorted, whereas stream deposits tend to be very well sorted. Now, one of the most important depositional features created by running water are what we call deltas. And deltas basically form when you get a river or a stream that's traveling relatively rapidly that hits a large body of water, typically an ocean or a large lake. When it does this, it's going to slow down the water, and therefore the load of sediment that's being carried inside that is now going to change or drop dramatically. It's no longer traveling as fast, so it has to drop a lot of that material. Now, you guys have learned about deltas when you learned about something like the Nile River. The picture that you're looking at right now represents the Nile River Delta. All that green you see, the reason it exists is because the Nile River was traveling, and when it initially hit the Mediterranean Ocean, it dropped a ton of sediment. Slowly over time, that sediment built up and made the land that is there now, which was very good fertile soil and allowed it to grow lots of crops in this otherwise deserted area. Now, how does the delta actually form? Well, if we look here, and I actually want to look more down at the picture down here. So imagine here you had your landmass right here, and there was that river that was running probably from all the way over here. And it enters the ocean. Now, when it enters the ocean, what's going to happen? That water is going to push out because it still has force. But as it pushes out, it's going to slow down, and so it's going to drop all that sediment. And you can actually see how it's starting to build up land here and here. And so the land is actually extending out. This wasn't originally part of the continent or whatever it happened to be. Now, as time goes on, more and more material is going to build up. Sometimes the original path can get clogged off, but you can get this offshoot. And so what starts to happen is you start to get this fan shape. And you see it happens here, and eventually you get this fit. And that's one of the identifying characteristics of deltas. Not only are they large amounts of sediment, but they also tend to be fan-shaped. Now, one of the most important deltas in the United States is found right here. The state of Louisiana is almost exclusively formed by a delta from the mighty Mississippi River. Okay, the Mississippi River, if you look at it down here, would have come down like this. And almost all of this material down here was the original delta. Okay, and if you look here, this is what we think it originally looked like with the river coming out. You see the little branches there. Okay, the famous bayous and swamps and Cajun country of Louisiana was mostly formed as this delta grows. And today you can actually see, okay, the growing delta out here, and this is incredibly important. All this material is getting washed out of the Mississippi and dumped into the Gulf of Mexico, thereby forming this fan-shaped delta that is incredibly important and incredibly significant for all of us. Now, the last type of deposition that we want to talk about with rivers is what we call the floodplain deposits. Deltas are what we call channel deposits because they come directly out of the actual river, but we have what we call floodplain deposits. Now, remember, we talked about floodplains. Floodplains are the land on either side of the river that gets covered in water whenever the river reaches flood stage. Too much water in it, and it overflows its banks and it covers those areas. Those areas tend to be covered with large amounts of sediment. Why? Because as the river overflows, it's going to slow down. It's going to drop all that sediment there. Now, why are we talking about this? Well, living in the United States, you're going to hear quite often about floods happening in the Midwest around the Mississippi River. And you're going to hear a couple of the terms that we're going to talk about today, and those are going to be incredibly important. So maybe you'll be a little bit more informed as to what's actually going on. So if we look at the picture in front of us, we have a river in two different stages. We have the river at regular stage and we have the river at flood stage. The top picture would be the regular stage. It's an older river, you can tell because it's got the big meanders, okay? And then the bottom picture is the flood stage. Now, if you look at it, as the river is flowing like that, you see it's flowing on a relatively flat land, which is why it can meander. It's not cutting a deep valley, okay? It's doing more erosion on the outside parts than on the lower part of the river and all those things. Now, eventually, the river's gonna flood. All rivers flood. Large rainfall upstream, massive melting of the glacier, whatever happens to is going on, a hurricane comes, something happens, and so you get flooding. Okay, now when you get flooding, what basically happens is the water overflows the river's natural banks, and since the ground is relatively flat, it's just going to spread out. Now, how does that happen? Well, if we look at the second group of pictures here, we have the river in a bunch of different stages. Okay, and when we look at this river in a bunch of different stages, what we have is at flood stage, you see the river right there, the U-shaped channel, okay, and the water is overflowed its bank. And so some of the sediments get deposited. The coarse sediments are just the bigger sediments. Remember, we used that word when we talked about crystals. They get deposited close to where the river originally was, and the finer sediments get deposited away. Now, that can actually be good for soil development and things like that. Now, once the river goes back to normal, you get the development of these little hills on either side of the river channel that are called levees. They're called natural levees. And what that basically does is it makes the river channel a little higher. And so the next time the river wants to flood, it actually has to go above those. Now, it will go above those eventually, and the same process will happen. And slowly over time, you'll get these taller and taller and taller levees. Now, you're going to hear this word levee when we hear, news reporting about floods in the Midwest, because what they're always worried about is the river breaking the levees, the river breaking through the levees. Okay, because the levees are just sand and silt and clay and boulders and cobbles and all these things. If the river gets too strong or too high, it can knock those down. And so they worry dramatically about maintaining these levees. These levees are incredibly important for the people who live around rivers. All right, so the next thing we're going to talk about is beach erosion and deposition. So we're basically talking about what happens along the shorelines of islands or continents and how that edge gets broken down and what happens to those pieces after they get broken down. Okay, so what goes on along the shoreline? What kind of erosion do we have? Well, as the waves come in, they break, right? You've seen waves break before. They come in, they crest, and they fall over. Well, that cresting of waves weathers and erodes the shoreline. It chips away at the rocks at the edge of the continent or the island that we're talking about, and it carries them away. And when it does this, it's going to create very distinctive features along the shoreline. Those features are what we typically call sea cliffs, sea arches, sea stacks, and sea caves. Okay, so these are sea cliffs. So what's happened here? The water has hit and just broken away and broken away. And so you get these large cliffs, okay? Cliffs of Dover, if you've ever gone to Pebble Beach or places like that. What's basically happened is these rocks have all been exposed by this constant just bashing of the waves and bashing of the waves and bashing of the waves. And so you develop these sharp, jagged cliffs as the water has slowly broken away at the material that's there. You can also end up with sea caves like this. Now what happens here? These are probably marble caves. And what happened is as the water went in there, not only did it physically abrade and dissolve those things out, but you had chemical weathering, which would be the dissolution that I just mentioned. Okay, the calcite would have broken down, and so you get the development of these sea caves. You also saw it in the picture that we were looking at before. Okay, it kind of hollows these guys out. Okay, you can also get these guys. Okay, what these are the arches. Okay, now this is a perfect example of differential weathering. This rock is obviously much sturdier and much more resistant to weathering than whatever happened to be here. Okay, same thing with this. There was a difference here, and so you got differential weathering, and so you got this sea arch. These are very pretty. People love to take pictures on vacations. They're very scenic. Okay, and basically all that happened is the water has moved through here, and it ate away, and it ate away, and it ate away, and eventually you end up with this. Now, eventually, if you get bad enough storms, what can happen is this portion right here can get eaten away, and you can end up with a sea stack. All a sea stack is part of an arch where the arch has gotten eaten away. So there used to be a rock here, it got eaten away, and so now you're just left with these loose sea stacks. Okay, the interesting thing is sometimes you'll find rocks like this with no ocean. That gives us an indication that that area used to have an ocean and no longer does. We find these a lot in China and places like that, but some parts of the United States in the middle where we used to have an ocean in the time of the dinosaurs, you will actually find these as. Another type of erosion that we get is the erosion caused by what we call longshore currents. Now, longshore currents are ocean currents usually caused by wind that move parallel to the shore. Now, if we're looking at this picture in front of you, okay, so here you have the beach right here, okay, and here you have the longshore current moving this way, generated by the wind, okay, and this, you all understand this, we deal with this all the time. When you go into the beach and you start out swimming here and you're playing around, and then 10 minutes later you realize you're down here. Why? Because what happened is this current that runs along the shore, the longshore current, has drifted you downstream. When you go to the beach this summer, check it out. You'll notice this. The waves usually don't tend to come in perfectly straight in. They actually tend to come in at this angle. That's because this longshore current drags the water down there. Not only does the longshore current drag the water down, but all the stuff that gets dissolved or carried by those waves gets moved down. So what ends up happening is you get a movement of the sand grains. The waves come in, grab some sand grains, they get pulled back in through the tide, and what ends up happening is they slowly get moved this way. And so your beach grows here and gets smaller over here. So slowly over time, that's the process that happens with beaches. And that's all caused by this longshore. All right, so waves deposit mostly quartz sand, and they leave these deposits as beaches, sandbars, spits, hooks, and barriers. If you want to pause it so you can rewrite them down, that's fine, but I'm going to move forward. So what are beaches? Beaches are the most common form of deposit that you can have. What happens? The waves come in. As they come in, they carry the material. They drop off that material here. We all understand this. We've all gotten sand deposited in our own bathing suits. Now, sometimes that sand, though, doesn't get deposited on the shoreline. It gets deposited off a little bit from the main shoreline, and it builds up as a hill underwater that eventually breaks the surface. We call this a sandbar. Sometimes those sandbars can rejoin the mainland, and they can create what we call a spit. All a spit basically is a sandbar that grew enough to rejoin the mainland. Sometimes a spit will grow so big and the waves will start to curve it and will actually make what we call a hook. And if this hook reconnects on both sides, it can form what we call a lagoon. The last thing that we want to talk about are barrier islands. Barrier islands are basically these big masses of sand that build up off the coast. They look like this. Now, they look really pretty, but they can actually be quite dangerous. Why? Because people like to live on them, like you see in the picture here. But when a storm comes in like this, it's going to devastate the barrier island first. And this is what we saw during Hurricane Sandy. They're called barrier islands because that's exactly what they do. They act as a barrier for the mainland for the storms that come in. So this would be places like Long Beach and stuff like that out on the south shore of Long Island. All right, guys, so that does it for erosion and deposition. We are done. Make sure that you go and take your quiz on Test Wizard. And if you have any questions or anything on the test, remember we have office hours on Monday. All right, guys, good luck. Bye.